This time it's the second session that we will show you, in this case, the NooBaa ecosystem, or more specifically, we're going to show you the integration with Kubernetes, Openshift, and what we built on top of the NooBaa technology in order to provide access to it from the Kubernetes Openshift platforms. So my name is Guy Margalit, Nimrod Becker with me, and we'll start. So the first topic, and it's the major one here, is the noobaa-operator. And I'll take a step back and explain just maybe less than a minute what it means. So operators is a concept for Kubernetes controllers, which means that whenever you have a software or a complex workload that you like to deploy and then make even day 2 operations on, so instead of providing just any type of APIs, the concept in Kubernetes is to provide custom resource definition, CRDs, and an operator, which is a controller or a set of controllers that listen on these CRDs, and they basically get APIs based on these CRDs and apply them to the backend of that system. In the NooBaa case, we would like to provision NooBaa itself, provision NooBaa systems inside of Kubernetes, and then also connect NooBaa to backing stores, create bucket classes, which are policies for buckets, and then provision buckets for applications. So this is the context of what we're talking about, and I'm going to show you first just these pieces that we have. So in the last talk, we discussed the noobaa-core, which is composed of several components on its own: the endpoint, the core itself, the database part of it, and the storage daemon, which we can use to provision storage from volumes. So that's the left side. On the middle side, the operator itself, this is basically a pod inside of Kubernetes, something that runs and uses the Kubernetes API and watches for CRDs. So it comes with a set of 3 CRDs, or even a little bit more now with all the package. So it's a bunch of CRDs that the operator listens to, watches for, and whenever it sees changes or requests, it's called reconcile, but it's like you define what you'd like the desired state to be, and the operator is responsible to apply it onto NooBaa. So that's the operator itself. And the last piece is actually the same code for the operator is a command line. So we took the same code base of the operator, we exposed it as a command line so that you can run all the functions from the command line to create these CRDs, to list them, to get information from them, and I'll show you through this presentation and demo, which will use the command line tool extensively. So these are the pieces, and not just another word about the ecosystem. So there's a concept called Operator Hub for Red Hat, which is available both for Kubernetes and Openshift. So it's available for both. And noobaa-operator is available differently on each one. So for Kubernetes, the upstream, it's available directly as a noobaa-operator on the left side here. And for Openshift, it's part of a bigger product called the Openshift Container Storage. And the operator for Openshift Container Storage includes the noobaa-operator, but bundles it in a bigger offering and a solution which includes also block, file, and much more solutions. So this is where it's available. In Openshift, you can get to Operator Hub directly on the Openshift console. From Kubernetes, it's more of a CLI installation, but it's using a component which is called Operator Lifecycle Manager, OLM, and the OLM is responsible for deploying the operator itself. let's put that aside because it's a complex talk and I don't want to go into the OLM internals now. So I'm going to use for this talk only the CLI for installation. It's a little bit simpler for the purpose of this talk. So this is the CLI. I'm going to keep these few slides here and just show you the actual command line and show a demo. So to begin with, I'm using Minikube locally, and I have my noobaa-operator CLI installed. So I'm using Mac and I'm installing.
Okay, maybe increase the font.
Yes, sorry. Is it okay now?
Yeah.
Okay, so I'm using, I can show the instructions later, but I can install the CLI tool directly from Brew, and I have it installed already, so it's just going to say it's installed, I hope. Okay, and it's installed, and I have the version, which I don't want to reinstall. So this is the CLI tool. It's a little bit maybe too big. Okay. This is a CLI tool. It has the completions and anything you'd like to have. And the first step we'd like to do is just install a noobaa system in a namespace, which inside the noobaa namespace in this case. I'm just selecting that namespace and now I'm installing. So in noobaa install, it's going to be pretty quick in this case because I have all the images already preloaded. Minikube, so it's not going to take too much. When it's fresh, it just spends some time on pulling the images. But other than that, the actual start of the pods is not something that takes more than 30 seconds or so. So in this case, the CLI is, I'm going to just explain, it's creating the CRDs, which is something OLM will do it the same way from the hub. It's installing the operator itself, creating roles and whatever is needed for it, and the deployment for it. And finally, just tell the operator, create me a noobaa system. That's the only command that it needs to do from the CLI here. And now we're just monitoring what the operator is doing, and it's actually done. It created everything. It gave us a status that everything is here. There's some things which are not supported on this platform because it's Minikube and not Openshift with more capabilities, but it has noobaa up and running. And I can take a look at anything here. I have the core running, I have the operator. That's the first step. Whenever I want, I can also go back and see the status of this system and see everything is the same or not, something changed on this cluster, and I get all the information on how to connect it. So I have the management addresses, the S3 addresses, I get the decoding of the secrets for the management credentials on the system and the S3 credentials for the admin access on the system. Okay, and that's the first piece of the puzzle, how to get noobaa installed. It's already installed. I'm going to do one last thing here. I'm going to just open, I don't know if you can see it or not, but it's another CLI action called noobaa UI. It's just opening in another window, I guess. Yeah. Can you see my screen still in the recording?
Yeah.
Okay. So this is the noobaa UI, and I get the credentials for the UI as well, so that I can log in. And I think we showed the UI in the last talk as well. So this is the same thing, just on this fresh system. That's the first step. Let's go back to the presentation. And we made it to install a noobaa inside of Kubernetes. It's a great first step. And I didn't show you all the pieces, but there are CRDs involved. Maybe just spend a second on it before I go on. So if I take a look, there is one CRD which is called noobaa, or if I take all the CRDs, these are the CRDs we installed: the noobaa, bucket classes, backing stores, and object bucket claims, etc. And the system is being controlled by this CRD called noobaa, and if I actually look at all of it, it has a lot of status information, and it also supports a spec that I can change the behavior of the system for the operator to apply. So I can set a different images if I want to upgrade. I can set a different type of resources that I want to allocate for these pods, etc., etc. So this is just to give you a sense of what happened here. So it's this controller is running in a pod, read that CRD and applied it and created the NooBaa system underneath. Okay, going back to the presentation, if I find it, yeah.
Okay, so going back a bit to last time, where we talked about policies for buckets and resources that NooBaa supports, I want to show you how it's being handled or represented in the Kubernetes world. So if you remember, we talked about backing stores or resources which can be either on-prem or on the cloud, and we talked about policies which can cause either multi-site or multi-cloud or hybrid. So for backing stores, we have the same names represented in Kubernetes. We have backing stores which represent a single target which a bucket can reside on. It again can be all the options we discussed before. And bucket classes are basically a structure of backing stores which sets the policy of a defined bucket. So we can have a bucket class which gives us a hybrid between AWS and on-prem or multi-cloud, or again, all the options we discussed before. And these will be created usually by the administrator of the NooBaa system, and later they will be consumed by applications. So imagine that a certain administrator can create the resources he wants his user to use, and then the classes that he wants to give his applications. And then each application owner which comes and tries to develop or deploy his application can select the correct or the most appropriate class that he wants for his application. Again, these are the same things that we have inside NooBaa. You can see them in the UI, but this is the CRDs, the Kubernetes representatives of the same objects. And we can show a demo of creating a backing store and maybe editing a bucket class, just so you'll see how it's being handled.
Okay, so the first step, let's take a look at the status. The status will show us that we don't have any backing store. We don't have any backing stores here. Okay, we do have a bucket class which is default, but it's not active because we don't have backing stores. So I'm going to create a first one. It's going to just, for this sake of the demo, I'm going to use Google Cloud Storage. So I'm creating a new backing store and call it Gaga, and I'm providing it with a private key JSON file. Don't worry, it's going to be expired after the demo. And I'm going to redirect it to a target bucket that we created for that purpose. And what it does is creating a secret, putting all the credentials inside, and creating a backing store connected to the secret. So this is the structure that the operator can understand. Then the operator is basically taking this information and configuring NooBaa to use that backing store.
We could jump to the UI if you want.
Yes, I'll do that now, and need to go out from Chrome. Yeah. Okay, so here we have Google already updated here. If I show the resources, that's the resource name, and it's a Google Cloud Storage backing store. Okay, so that's a backing store, and it's configured and running. I can also see it if I take a look at the list. Okay, so that's configured. Let's take now another example and create a bucket class using this backing store. So we're going to create a bucket class with the same name, doesn't really collide, and just tell it to use this backing store as its only backing store in this case. It's going to create it, and it's going to be ready. So now, if I take the status of the system, you're going to see both of them ready and configured. I hope you can see them ready. It's yeah, okay, overlapping. Okay, so I have the backend store and bucket class ready. I don't have any bucket claims yet because we didn't create it, but we'll get to it very soon. In addition, we have a status for everything like that. So if you have a bucket class and you want to get a status for it, you can show it or backing store. So whenever you want more information about any of these, you can use the CLI, or we can also use just Kubernetes tools to get these entities and take a look at them more natively. So these are just Kubernetes entities, and it has a spec, and in this case it's a Google Cloud Storage. It's connected to a secret, there's a target, and there's a status that the operator maintains for it. Okay? Okay. Let's go back. Okay. In the next step, we have the, let's say, the storage infrastructure ready for applications to consume. Now, this is the object bucket claim is actually a concept that was copied from the PVCs, so the persistent volume claims. So for block and file, the model in Kubernetes is that applications do not communicate directly to the storage provider. They create a CRD, or it's not a CRD. It's a PVC is a native Kubernetes entity. It's not custom. So they create a PVC, and then the provisioner, which can be any type of storage provisioner, creates the storage, allocates the storage, and connects the storage to pods if needed. So that's the model for PVCs. OBCs for objects, for object buckets is a very similar thing, but it's a little bit different. It's only the control plane, so it allocates buckets and allows applications to get information on how to use these buckets, but it doesn't have the data plane the same way that block and file can hook into or mount into a pod, an existing pod. So it's a little bit different, but still the application would eventually need to use data plane using an objects to REST API, whatever the API for the object store. But the provisioning piece of it is very similar, and we'll show you that in a second. Just a little bit more information about object bucket claims. So the way that it works for the application creates a claim for the operator to watch. The operator is watching claims from all the cluster. And given that the claim is for that operator, based on, there's a field there called provisioner. If it's for me, let's say, I would start provisioning. I'll create a bucket and an account such that the account has only the permissions to use this bucket. So it's like a specific application access for a bucket. This is the concept here. It's direct application bucket. And then once the application gets back the claim, it gets back Kubernetes entities that I'll show you, a secret and config map. And once these are available, it can configure its S3 API to use noobaa S3 endpoint. So with the secret as credentials and the config map as the bucket name and endpoint address, etc. And then we can authenticate that account and do the actual placement based on the bucket classes and all of the rest of our policies inside noobaa.
Yes, so within the OBC, an application can supply a bucket class. There is a default one, so it doesn't have to, but whatever the case is, the bucket will be created with the desired policy that was provided.
Right. And then we get a complete control plane for applications on the Kubernetes APIs. And the only thing that is outside of the Kubernetes API is the actual data access API. Okay, so just to give you a sense of what's happening for the application, once the application creates an OBC, which is sort of something that the application brings with its deployment, so the same way that the application brings a stateful set, a deployment, pods, jobs, whatever the Kubernetes entities are, it will claim an object bucket using this kind of API, the object bucket claim. The storage class name here represents the reference to NooBaa, right? This is how we know that we are the provisioner of this claim, and we serve it. And this is just to be able to tell us to generate a bucket name and not specify an exact bucket name. And the reason is because the same YAML might be deployed multiple times, and we don't want to collide on the names inside of NooBaa. So there is a generated suffix to it. This is the claim. The operator sees the claim and creates as a reply the bucket inside of NooBaa, and then creates for the application these two entities, config map and secret. These two entities, if I jump to the next slide, can be mounted in somewhat mounted into a pod or an application using environment. So the environment can be loaded from these config map and secret into the pods that use the object store. And therefore, the application can use these environments like the access key, secret key, the bucket name, for example. If it's a generated name, the name will also, the actual name of the bucket will be available with this environment variable, and the host itself. So then the application can configure its SDK or whatever the application is using to connect to S3 to use these connection details. So I'm going to show you that. It's made easier when I'm doing it through CLI, but if the goal is to automate, then typically you would use the actual YAML because you bring a complete deployment for application. So I'm going to take an example here and create an OBC from this bucket class.
While you are running that, I'll just note that on the OpenShift side of integrations, we do have all of these in the OpenShift UI, so you can create the bucket classes and the backing stores and even the OBCs in a more UI-friendly manner, but that's OpenShift only and not Kubernetes.
Right. Okay, so in this case, we created an OBC, and it's not created in the same namespace, so it's not part of the NooBaa system, it's part of the application namespace, which is called app1 here, and we're creating a bucket one, and specifying that the bucket class should be the same one that we created before. Okay, so that created, the only thing it created was create a bucket claim, the object bucket claim here, and then just monitor what happens. So we can see that everything exists here and loaded it, and we provide all the information from the system to show the same environment that we talked about before. So that's one piece of it. If you ever forget it, we can always go back and establish it. Okay, so that's bucket one, just app namespace. Okay, so it's the same thing. I can always go back and get the same information. So I also have here a simple alias that I can use, at least if I have this endpoint available, as in my case here. And this is using the S3, the AWS SDK, which is just a command line tool for S3. So I configured it using the access key, secret key, endpoint, etc. So now if I just do an S3ls, and I'm going to throw away my error because otherwise you're going to see an SSL warning, but it's not very useful here. You're going to see that I have access only to that bucket one that we provisioned. So it's just one bucket that this account can access. Although there's actually another bucket, and if I jump to the UI, you'll see there's another one available which I cannot consume. Okay, so there's a first bucket here which exists. I don't have permissions to. Okay, so that's one case. I can just give you another example. I can send some data to this bucket. This is just how I do it from the AWS CLI, and then I copy some of my source code to that bucket, and I can now just try and list all that. Okay, so the data, so we have the bucket, we have data on it. We can also cross-ref that and just go and see that bucket right here. We can see the policy here the same way that we configured using the Gaga backing store. You can see objects, the same objects that we uploaded. And we basically, the operator did what we asked here. And let's see if I have another piece here. So yeah, I want to show you how it looks like from more of an automated application here. So if I just take a look at the OBC config map and secret in that up1 namespace, so we basically provisioned these structures, right? The bucket 1 secret, the bucket 1 config map, and the bucket 1 OBC, so that any application that wants to load it from that namespace can go ahead and do that, right? So that's what we wanted to achieve here. And here should show us the same information, right? So that's the OBC. I can now also, once the application is done with it, so let's maybe, when I tear down this OBC, if I delete OBC bucket 1, right, so we deleted the bucket claim, and the operator should also remove the secret and config map, and also the bucket should be gone, right? So everything is teared down once the application is gone, unless we have a retain policy for the storage, which is a different case. In this case, it's temporary storage, so the retain policy is delete. In another case, it's going to be retained, and the bucket will be remain. Okay. So I think that concludes what we wanted to show on the integration. It takes the object APIs for provisioning and creates and abstracts the backing stores and bucket classes and claims for buckets, so that applications and administrators can automate on top of Kubernetes. That's the first step. The first topic that we wanted to show in this presentation. The next topic, and before we go to that, if you have questions. Yeah.
Hi, can I make a question now before you go ahead with the presentation?
Yes.
It's Christian.
Yeah.
It's Christian from Dublin. Hi. So just a quick question on the object bucket claim. So from what I see, the object bucket claim is not linked to the pod the same way you link a PVC to the pod, right? So because when you create a volume in a pod, you have to say use this claim. This means that when I start the pod, if the claim is not there, the pod will not start until the claim is ready. While with the object bucket claim, my understanding is that the two things remain separated. So in the pod, I just mount the config map and the secret. There is no control on whether the object bucket claim is actually there before I start my pod. Is this the case?
So not exactly. There is some part of what we say which is true. It's not mounted per se because it's not a block of file interface. There is S3FS and other ways that you can mount an S3 bucket, but it's not that context of what we discussed. But the other side of it is that once your pod specifies an environment that loads from a config map or secret, the pod will not start until this secret and config map are available. So in essence, the pod will only start once the OBC, the claim itself, is provisioned.
Okay. So this is where the link is done. Okay, with the secret and the config map. Okay.
Right. So if I do that, you see here on the right, I hope you can see it, when you do when you take a value from a config map or secret, the pod will depend on these.
Okay.
So you have a status that says the secret does not exist, I'm not starting the pod.
Okay. Okay. Okay, thanks. By the way, with mounting, I meant mounting like you could even mount a config map instead of giving it as an environment variable. This is what I meant, not mounting the bucket.
Yes. So you can do that the same way. I'm pretty sure it's going to behave exactly the same. So if the config map is not available, you're going to wait.
Yeah. Okay. Okay. Thanks, man.
Great question. If you have any other questions on the Kubernetes integrations, these CRDs, the processes of provisioning, it's a great time to ask it now. We're going to change topic to other integrations and roadmaps. So if you have something that you want to, in this context, you can ask now or even later. It's both work. Okay. So let's go on.
Yeah. Okay. So Guy showed the integration regarding object provisioning, bucket provisioning, and all types of policies. We do have other integrations with the platform as well, and I want to touch on the bigger one of those. So first of all, we wanted, like you've seen in the demo, Guy logged into the UI and used the credentials that the operator gave him back, and we wanted to have a smoother experience for admins. So we integrated with an SSO, basically with an identity provider. This way, any OpenShift or Kubernetes which has an identity provider installed would enjoy the SSO flow, and you can go into the NooBaa UI once you log into Kubernetes. This is only for admin purposes. We're not talking about application access. I will touch on that a bit later. On the side of metrics and monitoring, so one of the biggest projects in Kubernetes is called Prometheus. Prometheus provides a framework that scrapes all kind of pods for data, and then you can define all sets of rules for alerting, and you can build dashboards on top of these matrices. So we integrated with Prometheus, and Guy, can you show the UI, the /metrics route? So basically, it's a route that any service can provide and tell Prometheus to scrape the data, and every few minutes, Prometheus will go and retrieve all the different values that we provide. Then you can build, for example, we build a bunch of alerts on top of it, so we can define to Prometheus and say, okay, listen, if that specific value is lower than 80 for 5 minutes, send that alert. And so you can just in a non-programmatic, more like a descriptive way, set alerts. There's another project called Grafana, which we won't show, but you can integrate into Prometheus and set all kinds of, build your own dashboards on top of these values. So this is also something that we export. And the last thing would be auto-scaling. So if you remember, we talked about the NooBaa endpoints, the S3 endpoints, which are stateless, and they basically do all the ingest pipeline. They perform the dedupe, the encryption, and the compression. And what we wanted to do is give the ability to scale up and scale down as the load increases or decreases. So Kubernetes provides a way of setting metrics and probes to understand when it needs to scale up a certain pod. In our case, we're talking about memory and CPU. So if, for example, Kubernetes will detect that the endpoints are under CPU stress or memory stress, it will spin more endpoints. And once the stress is over, let's say the night comes and everything goes down, it will spin them down and will release the resources. This is something which is currently being worked on, and it will be available in the next version. And I wanted to, with that, touch a bit about the next versions, because I know it's also an interesting subject. So go ahead. So we just an example of things that we are working on the coming 2-3 versions. So bucket policy for access control. This is an S3 feature that gives you the ability to fine-tune which user, which roles can access and do what on each bucket. S3 locking, which is basically a policy that says which objects can be deleted, overwritten, moved, whatever. Security tokens. So we talked about SSO for admins. We want to have the same ability for applications to use an existing user database. Active Directory is usually the most common one, and use the security token service to get the token from Active Directory and authenticate to NooBaa using that token. So this is also something we started working on. We want to have the ability to have high availability and sharding on top of several Kubernetes clusters. So basically it's a cluster of NooBaa on top of Kubernetes clusters. And as Guy mentioned last time, NooBaa was very focused on high bandwidth applications, and we want to have optimizations done for small objects as well. These are all NooBaa features. We have several platform integrations we want to tackle as well. I talked about auto-scaling for endpoints, about CPU and memory. We want to have custom metrics, which basically it's a specific probe that you write, and you know better than just CPU and memory. You can count requests, you can count buffers, you can do whatever you feel you need to, and have a better way of auto-scaling for Kubernetes. This is something we want to do as well. And we want to do storage auto-scaling. So we have for on-prem, or not even just on-prem, we have PV backing stores, so we can use existing storage. We want to have an auto-scaling for that as well. So once storage runs out, we can simply spin another pod, another PV, and increase the storage, obviously if the admin enabled it. So that's just a bit of touching on the roadmap. This is the NooBaa roadmap. This is not the OCS, the Red Hat product roadmap, which I cannot discuss currently, but I guess it will be available at some point in time. Any questions on other integrations that you might have heard and I missed mentioning on, or specific features in the roadmap that you don't see?
I have a question on the S3 worm locking. Does that push down worm requests from NooBaa to the backstore to prevent the data from being deleted underneath you?
That's a good point, and we didn't think about it. The idea here was to have it like AWS, so it means on the NooBaa level, not when you go ahead behind the scenes and delete the chunk that we save on the cloud or whatever.
There's two pieces to one probably. There's the API itself to lock and unlock, and there's the certification, if you want the actual worm certification. I'm not sure, maybe for what you're saying, for certifying worm, maybe that needs to be all across the stack, but I'm not sure.
So I think there's three things. There's the API, there's the certification, and there's implementing the function to prevent it from being deleted without actually getting the certification, which is a big headache to get certification, and there are a lot of details in it. But there's still, I want something where someone can't delete the data. I don't need certification, but I really want to make sure no one's going to go around behind me and delete the data.
But that's a good point. Once a worm policy is set on a NooBaa bucket, to propagate that onto, if the backing store supports it, obviously, let's say S3, which does support it, to propagate and also lock that specific bucket. That's a good point, yeah. Any other questions?
Okay. Any questions from remote participants?
Okay, so what I'll do is I will share, once we upload the video, I will share the instructions of how to get what we did, at least locally on Minikube or another cluster, so that if someone wants to try it on its own, anybody can use it. And thank you very much.
Thank you.
Thank you.